Okay, so let's get right into it. We've all had fun playing around with generative AI, right? But now it's time to get serious. We're going to tackle a huge question. How do we take these incredible, but sometimes totally chaotic models and turn them from what feels like unpredictable magic into actual, robust, reliable software?
And look, it all starts with a question that I am sure every single one of us has yelled at our screen in frustration. And that is, why? Why does AI get things so spectacularly and sometimes hilariously wrong? This isn't just about the AI getting a historical fact wrong or writing a funny poem. We're talking about real world consequences. Just imagine this scenario, and this is pulled from an actual system failure. A user asks about a clinic's policy, and the model just invents one. Out of thin air. Suddenly, the stakes are incredibly high. This is exactly where a simple oops turns into a massive liability. So that leads us to the most important point of this entire conversation. The fix for this kind of problem, it's not about endlessly tweaking your prompts, trying to find that one magic combination of words. No, the real solution is a fundamental shift in how we think about this stuff. We absolutely have to stop treating AI like it's some kind of magic and start treating it like what it is, a piece of software that needs to be engineered. And this comparison here just nails that mindset shift perfectly. On one side, you have the magic approach. It's totally unpredictable, it's hope-driven, you just cross your fingers and hope for the best, and the whole thing is a complete black box. But on the other side, you have the software engineering approach. This is all about being systematic, being test-driven, and, this is key, building a system of contracts. That just means every single component has a clearly defined job, and we can actually hold it accountable for doing that job correctly. So the big question is, how do we actually do that? Well, we've got to start with a proactive approach right from the get-go. And here's our blueprint for building this stuff reliably from the start. It's called the AI Reliability Pyramid. Now, if you've ever worked in software, this is going to look really familiar. It's basically the classic testing pyramid, just adapted for AI. Down at the bottom, at level 1, we have our fast, simple unit tests. Then in the middle, we've got regression tests, which are there to make sure we don't accidentally break things that used to work. And then right at the top, we have our big evaluation sets that check if the whole system is actually delivering the right business value. It's all about building quality from the ground up. Okay, let's start at level 1, the base of our pyramid. Honestly, the fastest and easiest way to make your AI more reliable is to just test its output structure. I mean, basic stuff like, is it giving us valid JSON? Are all the keys we're expecting actually present? And this one is so important, does it know how to say I don't know or not stated when the information just isn't there? That one check alone can prevent a ton of hallucinations. All right, next up, we have to talk about something I like to call a silent killer, prompt drift. This is that infuriating thing that happens when you make a tiny change somewhere else and suddenly a prompt that worked perfectly yesterday is just broken. The way you fight this is with a golden set of regression tests. This is your safety net. It should hammer the system with tests for handling missing info, weird adversarial phrasing, and just plain strange inputs to make sure your prompts are tough as nails. Now, for anyone out there building with RAG, that's retrieval augmented generation, this is for you. This is absolutely critical. You have to test the retrieval part of your system. Is it grabbing the right document? Are your filters working? But listen, the single most important test you can run is for an empty retrieval. What happens when your system finds nothing? If the answer isn't, I can't answer that, then my friend, you have basically built a hallucination machine that's just waiting to go off. And of course, as our systems get more and more complex, using external tools and multiple agents, our testing has to evolve right along with them. We need to be asking, can the AI actually pick the right tool for the job? What happens when a network call fails? Does it handle it gracefully? Does the main orchestrator agent send tasks to the right specialist? Every single one of these is a potential point of failure that we can and absolutely must test for. Okay, so let's say we've done all this. We've built this fantastic, robust testing suite. We're feeling pretty good about ourselves. But what happens when that beautifully well-tested system still breaks out in the real world, in production? Because, let's be real for a second, it's going to happen. Well, that is exactly when we switch gears from being proactive builders to being reactive debuggers. And you better believe we need a solid plan for that too. So let's talk about the triage algorithm. Think of this as your systematic guide to playing detective when your AI goes off the rails.
Now, this is not about randomly poking around and guessing what's broken. It is a systematic process of elimination. First, you confirm the symptom and figure out how widespread it is. Then you ask a series of questions. Is the problem in the retrieval step? If the answer is no, you move on. Is the problem in the generation step? And if not that, is there an issue with how it's using tools? By isolating each part like this, you can find the root cause way, way faster. All right, time to put on our detective hats. Let's start with step one, which is often the biggest culprit in RAG applications. Is this a retrieval problem? So here are the classic telltale signs you should be looking for. If the AI's answer is super vague or the sources it cites are totally irrelevant, your number one suspect should be the retrieval step. And the checks are pretty straightforward from there. Did retrieval even return anything at all? Maybe your filters are way too restrictive, or hey, maybe your data index is just stale and out of date. This checklist gives you a really clear path to follow. Okay, but what if retrieval looks fine? You check the logs and it's pulling back all the right documents. Well, then we move on to our next suspect. Step two, is this a generation problem? So this is where things get interesting. This is for all those failures where the AI has all the right information right in front of it, but it still gets the answer wrong. This is where your prompt engineering really comes under the microscope. Does your prompt strictly enforce answering only from the sources? Maybe the context window is just bloated with too much junk and the model is getting confused. Or maybe it's something as simple as your temperature setting being cranked up too high, making it get a little too creative when you just need the facts. And finally, if both retrieval and generation seem to be working just fine, we look at the last major piece of the puzzle. Step three. Is this a problem with how the AI is using its tools? This is all about those integration points, where your AI has to talk to the outside world. Are the tool calls failing because of a network issue or, a classic permissions error? Is the agent getting stuck in a frustrating loop, asking for the same info over and over? Maybe the schema that defines the tool isn't clear enough for the model to even understand what it's supposed to do. These are the kinds of nitty-gritty questions that solve those tough integration headaches. So let's recap. We have a proactive strategy for building and testing, and a reactive algorithm for debugging when things go wrong. But I really want to leave you with a powerful metaphor that ties this whole engineering mindset together beautifully. And that's the idea of training an AI sniffer dog. This quote really gets to the heart of it. Testing is training a sniffer dog. You don't hope it behaves, you expose it to the exact smells it will face. I just love that. We're not just hoping for good behavior from our AI, we are actively, purposefully training for it by exposing it to controlled failure scenarios over and over again. So what are these smells that we're training our AI sniffer dog to find? Well, they're the exact failure modes we've been talking about this whole time. Things like adversarial prompts, tool timeouts, stale data, and especially those empty retrieval results. Every single test case we write is just another scent that we're teaching our dog to recognize before it becomes a problem in the wild. So here's the bottom line. Building reliable, production-ready AI isn't an accident, and it is absolutely not magic. It is the direct and, frankly, predictable results of applying rigorous, systematic software engineering principles to the problem. And that really brings us to our final and maybe most important thought. As these incredibly powerful tools get woven deeper and deeper into our lives, the conversation has to change. If we now have the blueprint, the engineering mindset to build AI that is this reliable, what's our excuse when it's not? Something to think about.